So, we're going to start with Earth's interior. We're going to have 4 different sections to this, but today we're starting with Earth's interior. And the first question we're going to answer today is, how have geologists learned about Earth's interior structure? Okay, and we have 2 main types of evidence to learn about Earth's structure. So geologists have used 2 main types of evidence to learn about Earth's interior. First one, which we will label 1. Okay, direct evidence from rock samples. These direct evidence from rock samples. In other words, rocks drilled from deep inside the Earth allow our geologists to make inferences about their conditions. So, rocks saw a hand go up.
What does the geologist part say?
Up here?
Yeah.
Geologists have used 2 main types of evidence to learn about Earth's interior. Okay. Then we have indirect evidence. Right there in the hashtag mood. Evidence from seismic waves. And seismic. Okay, so seismic waves produced by earthquakes allow scientists to measure the speed in which they travel, giving clues to the structure of the planet. Speed at which. Okay, so we have 3 main layers, and I'm going to I'm sorry. giving clues to the structure of the planet. Okay, and we have three main types, three main layers. All right, so I'll pause for a minute, let you guys catch up. The first layer we're going to talk about is the crust, which is the layer of solid rock. It is the layer of solid rock that forms Earth's outer skin. It includes both dry land and ocean floor. Okay, we have the oceanic crust. Which consists mostly of a rock called basalt. Actually, I've never really learned how to say that. It's either basalt or basalt. Or basalt. Or I could be putting the emphasis on the wrong syllable. Yes.
Wait, you want me to search it up on dictionary.com and then use a little...
Right. So it could be basalt. Basalt actually sounds good. So there's the oceanic crust, and then there is the continental crust. Okay, the continental crust is the crust that forms the continents.
Or it says all three pronunciations are correct.
There you go. It's the crust that forms the continents. Consists mainly of granite. Continent consists. Okay. Then we have the mantle. Okay, the mantle is a layer of solid there's the mantle is a layer of solid hot rock 40 kilometers beneath the surface on average. and it is divided into layers. Okay. It's like an ogre. Ogres, they have layers. Okay, there's the lithosphere, which is the uppermost part of the mantle. Yep. Okay, it's the uppermost part of the mantle. Okay, and it's the crust for the ridge layer. It's the uppermost part of the mantle and the crust. Crust for the ridge layer, about about 100 kilometers thick. There is the asthenosphere, which is one of the coolest words that I've learned in this process. The asthenosphere. Yeah. Okay, the asthenosphere is the softer part of the mantle. Below the lithosphere. Which is hotter and under increased pressure. Okay, I'll let you guys catch up because we have one more to do. Actually, you know what? I'll leave it. I'll do this. And then we have the lower mantle. Can you be more specific? Lithosphere? Asthenosphere? Asthenosphere. A-S-T-H-E-N-O. Astheno. Then underneath the asthenosphere is the lower mantle, which is the solid material extending all the way to the core. And then we have the core. Worst sci-fi movie ever made, by the way. The Core. It's horrible. At least the science in it is horrible. There might be a good story there, but I couldn't sit through it thinking how bad the science was. Terrible. There are some really good science movies out there. The Martian, Arrival. Okay. There's some great science movies out there. Not The Core. However, just because The Core is a bad movie does not mean that it does not exist. We do have The Core. Okay. It is mostly made out of iron, and nickel. Okay, and those are the symbols next to it. Okay, it consists of two parts. It is the outer core, yes. No, that's Ni. This is not a smiley face. It is parentheses around the letters capital N, lowercase I, which is the chemical symbol for nickel. Okay, the outer core is a layer of molten metal. Molten metal. That surrounds the inner core. Okay, and then we have the inner core. Okay. And the inner core is a dense ball of solid metal. Okay. And it is the movement of the liquid outer core that creates the Earth's magnetic field. Okay. Okay, it's the movement of, this is a new word, this is called ferromagnetic. Okay, the iron in the outer core, the liquid iron in the outer core, acts as a big magnet. And that is what creates the magnetic field around Earth. That's why our compasses work. That's why a solar wind gets deflected from us. And it is the motion of the particles that travel through our magnetic field that creates the northern and southern lights. You guys have seen pictures of those? Okay. That light is caused by the particles traveling from the sun, passing through our magnetic field. That process creates light, and really, really pretty ones, because our magnetic field is concentrated up at the poles. There are also other effects involved with the magnetic field, which I geek out about because, physics teacher. So that's all you have to write. And we'll stop there for today.